Welcome to JHEP's lesson on atomic mass. Have a look at your hand. Take a look at it. Look at that speck of dust just lying there in the middle of your hand. Even if you can't see it, just imagine that little speck of dust. Now try to weigh it. Try to imagine how much it feels. Is it 0.0000000000005 grams or micrograms? We don't know, and that is the same with this atom as well. This is all theories. Electron microscopes still can't see properly the atom, okay? Mostly because electrons are moving all around the place and technology hasn't really developed that much. And that's what we're working with. So we need to compare it. We need to compare this mass to something. We need to find a nice way of comparing masses with each other in order to understand chemistry. And the relative atomic mass is the weighted mean mass of an atom, atomic atom, of an element compared, because we always compare the relative atomic or isotopic or compounds or formula mass with 1/12 of the mass of an atom of carbon-12, as that is the international standard. So in a sample of any element like carbon, say for example, there's usually different isotopes of it. So we have 24% of carbon-12 here and 76% of carbon-14 here, and we need to find the relative atomic mass of carbon, the weighted mass of carbon. So what we do, we change the percentage into a decimal by dividing it by 100, and then we times it by the mass. And we do it for the second one as well. 76 divided by 100 equals 0.76. Then we times it by 14. And that would equal 0.24 times 12 equals 2.88. And 0.76 times 14 equals 10.64. All you need to do now is add it up. So 2.88 plus 10.64, and that equals 13.52. In the exam, they may want you to do it to two significant figures. Say for example, that answer would be 13. If it was to one decimal place, it will be 13.5. If it was to four significant figures, it will be 13.52. The relative isotopic mass is the mass of an atom of an isotope compared to 1/12 of the mass of an atom of carbon-12. And all that means is that the mass of, like, carbon-13, say for example, the mass of carbon-13 means that the relative isotopic mass is also 13. That's all it means. This mass here of carbon is also the relative isotopic mass. The relative molecular mass is the weighted mean mass of a molecule compared to 1/12 of the mass of an atom of carbon-12. So all we need to do to find out the molecular mass of CO2 is to look in the periodic table and find out what the atomic mass of carbon was and the atomic mass of oxygen, and obviously times that by 2, seeing as there's 2 here. So the molecular mass of carbon is 12, as we know, and the molecular mass, well, the atomic mass the atomic mass of oxygen is 16. Times that by 2 is 32. Since they're joined up together, you add them together, and that makes 44. And that is your MR. So when you come in contact with the solids equation, where you have the number of moles equals the mass over the molecular mass, the m over mr, you know exactly what you need to do. The relative formula mass is just basically exactly the same as the relative molecular mass, but we have stronger and giant covalent bonds and giant ionic forces acting upon it as well. So instead of using this relative molecular mass, we use this relative formula mass, and the only thing that changes is literally formula unit and molecule. That's the only thing that changes. As you can see, it's exactly the same. And to do that, look in the periodic table, find out what the atomic number of iron is, find out the atomic number of, and times that by 2 by the way, and find the atomic number of oxygen, times it by 3, and you get your answer. And that is it for atomic mass.